So this video we'll be talking about how aspirin inhibits certain enzymes and what kind of functions the aspirin has. So we'll start by saying that this is the aspirin molecule. Um, over there on the right, so it can stay during the whole video. Now, prostaglandins are derived from fatty acids from the cell membrane. Actually, they break off from the phospholipid bilayer through a mechanism of an enzyme called phospholipase A2. And then the derivative of this reaction is this molecule here called arachidonic acid, or 15 HETE. After we have this molecule, another enzyme called cyclooxygenase. This creates an intermediate an intermediate molecule called prostaglandin H2, which is this one. And the name of the molecule that we have, cyclooxygenase, basically it creates a cyclo here and adds also oxygens to this new molecule. After that, this is molecule 3. Now this intermediate molecule, prostaglandin H2, doesn't stay like that. By action of it can take several paths. I'm gonna mention 3. PGE2 prostaglandin E2 isomerase. Isomerase is this molecule and gives us prostaglandin E2. Another pathway, thromboxane synthase, gives us this new molecule, thromboxane A2, and PGF2 prostaglandin F2 alpha reductase gives us this molecule, prostaglandin F2 alpha. Now, let me talk a little bit about prostaglandins. These serve various functions. For example, prostaglandin have a mechanism to protect the stomach from hydrochloric acid, basically through creation of or secretion of more mucus membrane, or mucus basically, in the inner lining of the stomach that protects us against its own acid. Hydrochloric acid. Prostaglandin serves as also vasodilators, helping lower blood pressure and taking more of the white blood cells to an area where it's needed. Also, prostaglandin act on the hypothalamus to increase body temperature. In this case, you get a fever, you're sick, you get a fever. Prostaglandin, you have to thank that function to them when they act on the hypothalamus and you get fever to basically achieve homeostasis. If you have an infection or other causes. Now again, prostaglandin causes inflammation through the cells with mechanism of immune mechanism pathway to also help you when you have also a pain, basically pain receptor. Also numbs the pain receptors as well. Now we can talk about acetylation. Basically, we say that acetylation has in this case salicylates, it's a non-selective COX inhibitor. Why is it an inhibitor? Because it acts on that molecule, and we can say that it's causes acetylation. Basically, it's an irreversible inhibition. Aspirin here, this is a molecule can basically go either two routes, binding to the active sites of serine 530 hydroxide in the thrombo, or I should say in the prostaglandins, or can bind to serine 516 hydroxide. In this case, it's the active site of both, and this gives us salicylic acid. And when the inhibition happens, we can see the PGG2 inhibited in this case, and basically it stops prostaglandin synthesis. On the other hand, when the aspirin binds to the isomer site of COX 516 and position 516, it basically switches the catalytic activity. This time PGG2 is inhibited, but some of these molecules, these long molecules, are formed again, and then this gives us or forms leukotrienes. Leukotrienes in some cases are or in this case create mucus, but in the lungs, and that is something that you don't want to give people that have asthma, and this can be something that can cause asthma. Going back to the antithrombotic effects of aspirin, inhibits PGH synthase by the irreversible acetylation again of a specific serine molecule, like this one here. And then also antithrombotic when it's used as platelet aggregate inhibitor, where people with cardiac disease can also benefit from it when it binds to this site. I hope this has been a good explanation of how prostaglandins are inhibited by aspirin, and I hope you have a good day. Thank you.